Okay, hi. My name is Frans. I'm the CTO of a company called New Orbit. We're based just this side of Oxford. So I'm here to talk to you today because I've been building software on Azure since 2011. And this is where I need to get to manage your expectations a little bit first. So in Azure, I consider myself an expert on Azure anyway, but there's about 10 different ways you can host a website in Azure. There's about 20 different ways you can run a database, and that's just Azure. Then you got all your other clouds as well. So the probability that I'm going to give you an answer that is exactly right for any one of your circumstances tonight is basically nil. What I am going to do is try and help you identify the questions that I think you need to be asking of yourself and of your tech teams and the other people you work with, and that's really my goal today. Now also, I specifically work with Azure. I'm going to make this as generic as I can, and most of what I'm going to talk about applies to all of the clouds. I will use a few Azure examples just because I happen to know them, but in all honesty, all the clouds are brilliant, and it really doesn't matter which one you use. We only chose Azure back in 2011 because we figured that the Microsoft brand was easier to sell to our customers. That was the only reason we chose it. So, without further ado, the structure, I'm going to cover some technical and cost considerations first. This is where you get the pitfalls, the things where I see people fall off and make mistakes and spend way too much money going into the cloud. Then I'm going to talk a bit about security and compliance. It's a big hobby horse of mine. I'll try not to talk about it for too long tonight. Then we're going to have a little break, and then we're going to get the panel discussion. So what would probably be best is to keep the questions for the whole panel, because again, I only know one cloud. Between the four of us, we know most of the cloud, so it makes more sense to ask it to the wider group. Okay. Just check my time so I don't run over. That's what we got. Okay, so just a bit of terminology. Can I just check how many are already in the cloud sort of in this room? So a good few of you. Okay. So let me just cover a little bit of terminology, and I'm not trying to be exact here, but it's just so we all have a common language. Firstly, we got the platform as a service concept, which is, or PaaS. These are all of the things where you are not running the infrastructure. You are just putting your code into something else that runs the code for you. So there's, AWS Lambdas, Azure Functions, Azure App Service, all of those kind of things. Your managed databases, your managed monitoring, all of those things where you're not having to deal with the underlying stuff. And then the other side of that is infrastructure as a service. So that's things like your VMs, your self-managed databases, and so on. You're not managing the tin, but you are asking for, can I have a VM running a particular operating system, whatever. Again, just terminology. And then, of course, the things we have in the middle, like the network stuff, again, most of the clouds allowed you to set up virtual networks. So, yeah, you're not playing with cables and stuff, but you can still get down into playing with ports and all that kind of stuff. And it's sort of a bit managed and a bit unmanaged. And things like Docker. Docker, how many here use Docker? Yeah, so it's a weird beast, isn't it? Because in the cloud, what is inside your Docker container, indeed, what image your container is based on, that's down to you. But you would typically stick it into a hosted Kate's service or something like that. So it's a weird mix between IaaS and PaaS. So there's some things you have to own yourself again that you didn't used to in the PaaS world, and other things you don't. Let's just establish some terminology. Okay. So, moving my software, technical and cost perspectives. So this is the technical side. And then we come on to the other stuff. The first thing is, when I speak to people about this, I find people go, when they're coming to the cloud, moving software into the cloud, they do one of two things, by and large. Writing new software is different. I'm talking about moving software, which is sort of what we're talking about tonight. The first one is, well, it's just VMs. Right? What I need to do is, my software runs in my colo location on some servers. So what I'm going to do is, I'm going to find out how many big VMs do I need, and I'm going to need 8 of these quad-core servers. So I'm going to deploy 8 quad-core VMs into, AWS or whatever, and I'm going to deploy my software, and away I'm in the cloud. Anybody done that or heard of people doing that? Yeah. The problem with that is, okay, that's not very bright, is it? Okay, there we go. It's just going to cost you a ton of money. Way, way, way too much. And almost all the benefits of the cloud you're not getting. Okay, it's just a terrible idea to do it that way. At least as an end goal. It's a great idea as a transition point, but don't aim to end up there. And then there's the other one. Rewrite everything, right? I'm sure you all have heard that one. Everything has to move to Docker. I even heard one company saying they had some SOAP APIs, and they said, no, if you're in the cloud, it has to be REST. So a 1-week project turned into a 6-month project, rewriting all the APIs for absolutely no reason. In all fairness, a lot of what happens is, especially in larger corporations, is that this is the one chance the tech team gets to actually pay down their technical debt. So if they can convince management they have to rewrite everything, there's a good reason they're going to ask for it. But if you're the guys who have to sign the checks, you've really got to challenge that, right? Because it's going to cost you a fortune in development. It's going to push your timescales out, and you're into the whole cost of delay thing. So what should you do? Well, something in the middle. Of course, there's always that, right? It depends. And I'll give you some ideas about how I suggest you approach it. But try not to do either of the extremes. It will just waste money. So now when you start actually moving it, looking at what you need to do, the practicalities of how you're going to move, these are the 3 main things I see people falling off. And I'm just going to go through these. The first one, oh, wrong way, sorry. This works the opposite way to mine. Macs are always different. There we go. So if you're in Colo or your own thing, even if you're running anything on VMs, the general idea is if it takes you days or weeks to get a new server up and running, get everything deployed on it, what you always want to do is make sure you have plenty of capacity to deal with your worst case scenario, okay? And that's great in that scenario, but when it takes you seconds to get new servers, or at worst minutes, it's just a waste of money. So you need to challenge yourself when you start thinking, I need this many servers. And I see it all the time. So I see clients coming to me with, I got this software, I want to move it in, I need this many big servers. And it's like, you probably don't 99% of the time. So just start challenging yourself a bit. If you can dial it up in 2 seconds, why pay for all of that capacity all the time? So here's some practical things you can do. The first thing, and if you take nothing else away, remember this one thing, okay? In Colo, what you would typically try and do is have a few large servers. For lots of reasons. It's more cost efficient normally when you have your own 10. It's easier to manage because you don't have so many servers to deploy on. In the cloud, try and have many small servers. You tend to pay exactly the same per core and CPU and memory in total. So it doesn't cost you any more to have lots of small servers, but it gives you a ton more flexibility. Now, that can be challenging when you have software that's running, and you might think that your software needs lots of capacity because it's under load when you're running it. But you might find that if you scale out, it'll be fine on much smaller servers, especially today where hardware is so phenomenally powerful. It'll run so much more than you think. What you will probably find when you test it, though, is a few hot paths that may use too much memory or have a few loops in it that are a bit bad. So the trick is to try and test, find those bits and fix them. And it's usually not that hard, so that you can run on many small servers. That really is the key to success, okay? Because once you do that, and then the second thing is, if you can use the PaaS solutions, do. Most people say, no, we're a bit special and we got this stuff and we need to be able to do stuff. So we just default into the VMs. The VMs are the least flexible and the ones that give you the least benefit of the cloud. So try and push the boundaries, try and find out what is it that stops you using the PaaS solutions and try and use them when you can. They will be, apart from anything else, they tend to scale a lot faster. Again, I don't know about the other clouds, but in Azure, if you say I need another 3 servers on my Azure function or Azure app service, it takes 2 to 3 seconds usually before they're up and running your software and serving requests. When I do the same thing with my VMs, 15, 20 minutes is the norm. And that might not sound like a lot of time, but to me 15 minutes is an age. Try a smaller scale than you think and then measure. Try and have fewer servers. Just try and see what happens. See if you can't get away with it and just measure it. Okay? Or if you really have to get more, measure it and see and just try and scale it down. Keep experimenting. You will be surprised how little you need to run big systems. I run some pretty big systems, and some of them, it's ridiculous. I run some systems that do thousands of requests on a single one-core server. And you'd never do that in your colo because it's scary, but in the cloud it's not scary. And one thing that's very overlooked, people are so in love with this automatic scaling where, lots of traffic, lots of servers spinning up. The really simple one is most systems have a pattern where they're more used at some times of the day than others, right? So what you can do in most of the clouds, even with the VMs that are slow and all of that, is set up scheduled scaling. So let's say it's busy between 8 and 5 normally on a weekday. If you then dial it down to 1 or 2 servers overnight, you've just saved 2/3 of your hosting cost, not counting databases. It's really boring and dull, but it will save you really big bucks. What's next? Here we go. Try sharing compute resources. A lot of people get really, I need a completely separate test system and a completely separate production system. That's fine, but a lot of the time there's virtual separation in the cloud, and you can actually share the same CPU and memory for your test system and stuff. It's a small thing, but that could easily save you sort of a few £100 on a smaller system. And if you've got lots of small systems, that adds up really quick. And finally, the array of options and levels of each service you buy in the cloud is bewildering, okay? And they always default to the most expensive fancy one. And we all like to think that our system is saving the world and we need the premium super deluxe version. On Azure, it's basic, standard, and premium. The others have similar things. I run almost everything on standard because it's almost always enough. Don't think you need the gold-plated version unless you actually have measured it and see that you need it, because they do charge quite a substantial premium quite often for those. All right. Oh yeah, abuse databases. This is a big one for me, and I often come across this one. So managed databases are fantastic because they do so much for you, right? As I like to tell people, I run about 200 databases in Azure. I don't have a DBA working for me, right? That saves me as much money as my entire hosting bill, not having, because you need 2 DBAs, right? They need to go on holiday. Literally not having DBAs pays for my entire hosting bill for everything. So that's great. However, because of the way they tend to be provisioned, is they're very, very strict about how much you can abuse them. There are these performance envelopes that you've got to fit inside. If you go out of that side of that, some of them have a bit of burst capacity and stuff like that, but it tends to hurt a lot, or they charge you a lot if you go outside the performance envelope. So what you find is that you should firstly measure your software, and you will usually find, and you can run like SQL Server on-prem and Oracle on-prem, you can run tools to measure the load on them. Do that, try and measure it on the load on your current thing, and find out where those few bits of code are that really abuses the system and fix them. As one really terrible example, I had a system that we did a lift and shift into the cloud for a client, and it was literally used for 1 hour once a week for one user to run a report. Running that on a managed database with the existing code would have cost £2,000 a month for the database because the code was so bad. So we obviously didn't put it on a managed database, but that's the kind of thing we're seeing again and again and again. So, and it can really catch you out. You might need to, as an interim step, if you just need to get it into the cloud, you can run SQL Server or Oracle Server on VM, and then you tend to get a much bigger performance envelope for the same price. You lose all of the other benefits, but it's a good interim step while you're fixing your code. And generally, this is the biggest problem I tend to come across when you're just moving software up. And especially if you don't measure it and if you're not aware of it ahead of time, you might just be killing your live server when you switch over. So do be really careful with this one. And just to put it into context on a saving thing, 45% of my hosting bill is on databases across everything I do. And our software is all written for the cloud to start with. You pay a lot for databases up there. Worth it, but it's a lot of money. Okay, here's another thing. When you write, when you write your database on-prem or write your code, it's your job to install a database server. It's your job to manage those kind of things. And having another type of database, another type of storage is expensive when you're doing it on-prem because it's more services for you to manage. So typically what you will do, naturally and sensibly, is to put everything into one database. So you have one database that stores absolutely everything, your files, your everything. And that's sensible. It's a bad idea in the cloud because switching on another type of database will take you a couple of clicks and you're there. Writing the code is another hour and it's running, and there's nothing to look after. So this, I like to call it multimodal persistence. That's meant as a joke. I don't know if it's a real term, but So, for example, you got things like blob storage for storing files. Don't put them in your SQL Server or your Oracle database when you're up in the cloud. Put them in the dedicated things. I have systems that stores, petabytes of data in blob storage, and I pay pounds per month for those kind of things. There's things like table storage is one of my favorite hidden tools on Azure that nobody knows about. It's similar to Bigtable over on the Google Cloud and so on. As an example, I have a system that does mileage checks on cars. So I have a main database with like 6 million cars in it. But then I also have 130 million mileage records for 20 million cars that I sometimes need. And I stick them in table storage. That's what I've done with it. If I need to look up all the mileage record for any of those 20 million cars, it takes an average of 4 milliseconds into my application. And I pay something like £3 a month for that. Okay? If I were to stick that in SQL, the performance would be 50 milliseconds at best for the response and a lot more money. Stick it into Cosmos or Mongo, 2 orders of magnitude more money for the cost. So have a look around, think about what you're doing and actually split it. That can really save you some really significant savings. Okay. Scaling. So this is the thing about what happens when I stick my stuff in the cloud and everything scales magically, right? So, I have my system and more users hit it and more servers spin up and the database spins up and all my users are really happy. That's what happens in the cloud by magic, right? Yeah? Okay, this is really what happens most of the time, unless you have actually managed to set it up and write your code. The users start spinning up. So what happens is you now have your little auto-scale monitoring sitting there, and that's that's an increase in traffic, but I bet it could be a spike. So I'll wait a little bit, and 5 minutes later, oh, yeah, something is going on. I better start spinning something up. And, 5, 10, 15 minutes later, you finally end up having some more servers. Lots of users unhappy in the meantime. But now what happens, of course, is that all of those servers are hitting your database, and now your database is breaking, sending back timeouts, and your whole system is slow. And then if you're lucky and have set it up well, then your database might auto scale, or you might have to pay somebody who goes in and starts styling up the thing. And depending on what scale you do, that might be a few seconds or it might be a few hours, depending on the database and all sorts of scenarios. I've had one database scale take 12 hours, and I've had others take a few seconds. It depends on what you're looking at. So if you just think that sticking it in the cloud and it's magically going to be perfect, you're wrong, okay? You've got to write some code to deal with that. So the most simple is the scaling with queues model. This is a very popular pattern. We've used it all for years in all sorts of software. And so this is not specific to the cloud. It's just a lot easier in the cloud. So the idea with this is that, so let's say you have a website that takes registrations for tonight, okay? So what you'd usually do, if you're just writing some code quickly, is you'd have a little website and it would have a little form on it. You go and fill it in, and then you'd have some inline code on the website that sends an email, writes to the database, and does a few other things, and that's all fine. The problem with that is then the website has to do a lot of work, and if all of a sudden lots of people hit it, then you have the problem we described before. So the smart way of writing that code is to have your little form, and then just drop all that data onto a queue, and then you have a little function picking it up that then runs it. Because that means if all of a sudden lots of users hit your site, the site's going to stay up just fine because it doesn't do anything. Most of my sort of smaller systems, they literally sit at like 2% CPU most of the time because all of the work happens down here. Now, as I said, you can do this easily on-prem as well. It's just that on-prem you have to manage your RabbitMQ cluster or whatever it is you have to do yourself, whereas in the cloud, you just use what's already there. You should make changes to your code here. You should identify those heavy things and start putting some of that onto queues. Not everything, but I do recommend that's where you start rewriting bits of code because that will really allow you to benefit from the cloud massively. Because these things you can scale out based on the queue length. So I have a system, for example, where every day at about 9 o'clock in the morning, something happens and one of these queues goes to 2,000 items. And then I go from 1 server to 6 servers in about 1 minute. And then half an hour later, they all shut down again. And that's just all automatic. And that really works really, really fast because you have the queue and it's an exact number it can measure rather than averaging things over time. So yeah, I just said that. And you will allow it to run this for your servers and a smaller database because if you limit the scaling on that, you don't risk overloading your server either. All that happens is rather than processing the event invite in 1 second, it takes 1 minute. Nobody really cares, right? But your database didn't fall over, your users didn't get kicked out. And it's dead easy. I timed it once. I sat down with somebody and pair programmed this, and they'd never done it before. End to end, setting up the queue, setting up the code, front and back end, and the function and everything. 57 minutes end to end, including teaching them how to do it. That's how easy it is compared to in the olden days on-prem. Figure out how to set up a Redis cluster, provision some servers, figure out the failover strategy for those. You're talking, a while before you're ready to go, right? And it's really, really easy. Do it gradually. Don't do it for everything, but just find the most heavy things, the most critical things, and do it, and then just measure. Keep measuring what's taking the time up there. In the cloud, you get a lot of tools for free that can tell you exactly where your hot code path is, so use them. Find out what's heavy, move it to a background processor over time. And finally, the bonus you get is it's so much more resilient. Because think about it, if you have a bug in your code that says, let's say the postcode is blank and that blows up the email sender or something crazy like that. If that code all sits up here, you lose all of those registrations. The data is gone, right? Or at best, you might be able to reconstruct it from logs. When you have a queue in place, all that happens is the message goes on a poison queue, you fix your code, and you rerun the queue message, and there's nobody's any the wiser. All they see is that it took a few hours before they got the confirmation email rather than a few minutes. The amount of times that saved my bacon, I daren't count. So I cannot recommend that enough. Okay, and if you do anyway, so this is what I suggest you do. This is my approach that I recommend. Most of it is fairly obvious. Do an assessment first. Make sure that you push people on what you can actually run in PaaS. Don't just take their word for it that it has to be VM or it has to be rewritten to Docker. Just have a look at what you can actually just chug in there. And you'd be surprised at how gnarly code you can actually chug into the PaaS offerings. Because it's in the cloud's interest to let you do even fairly complicated code in there. Test that database load. And one other thing, have a look for server stickiness. You know this thing about in-memory state that was so popular in some of the early Node Express things and some of the old-fashioned web forms and that kind of stuff. They really like to do in-memory session state. So the problem is that can be a real problem. You can just about do sticky sessions, but you've got to bear in mind you want to have lots of small servers rather than a few big servers, right? You've got to bear in mind the cloud will, without warning, unless you're on VMs, but if any of the PaaS, they will just take servers away from you and give you other servers. It just happens all the time without you even noticing. But if you have in-memory state, you're pretty hosed when it comes to that. So watch out for that one. And just, usually it's very easy to fix because you can normally plug in a more persistent state provider like a Redis provider or something like that. Then test it, wrong button. Still not used to this. Test it on the load, get it into a test environment, actually simulate with a full load. Again, I can't stress it enough because the chance of you having a hot code paths that are going to push that performance envelope you're getting on the cloud is really, really high. There are all sorts of boundaries, like in Azure, for example, at least anecdotally or historically, their Achilles heel was high write IOs. So you'd have stuff that if you started hammering the disks too hard, it would just keel over. I've even had SQL databases on the PaaS model dying because the IO was too high. And you just don't know that until you try. And that's, again, specific to each cloud where their pain points are. So you really got to test it if you have a big site. If it's a small site, just chug it up, then it'll probably be fine. But something big, you really have to try and figure out a way to simulate. Okay, really important. And then do the smallest thing you can. Get it up there, right? If you have to stick databases in VM, if you have to deploy most of it in VMs, fine. Just get it up there, get going. Pay the extra money you have to keep it going. But then step 4, monitor, measure, and iterate. Find out what the biggest problem is and fix it and then go back. The problem is, of course, you do this and then the powers that be say, that's it, you're done, it's in the cloud now, right? So you really got to make sure you sell them on this bit. And in my experience, moving this, it's really not unusual if you do this well, once you've done this for a little while, to be saving at least 80% on your colo costs. And I've seen that several times. It is just incredible how much you can cut your bills down by doing this well. But if you just stick it all up in VMs and don't do any more, then yeah, you're not going to save a lot. Okay. This one is one of my pet peeves. I have to just say that. So this, I often get this, hey, hang on a minute, oh, there's Azure and there's AWS and there's Google Cloud, and I don't want to be dependent on any one of those. I need my code to run on all of them, and I need to be able to just move it. And I know that I've got Docker and I've got Terraform, and I can just do that, and it's just press a button. It's true, but it's not free, okay? Because all of a sudden, you have to write to the lowest common denominator. You can't just write to those generic APIs. You can't, there's just a lot of cost in this. So yes, if you need that, you really, really need it. I get that. Most people probably don't need it. It's a fantastic toy for the techies. It's like one of those really cool toys, lots of fun to play with. It's very rare you see the business case actually stacking up. So when people start telling you that, oh, you have to do that, nine times out of 10, they're wrong. Okay, I'll hang my hat on that one. Sorry if that puts anybody off because you want to do it, but honestly, just reassess your business case if you think that's necessary. I mean, Azure alone have 47 data centers now. If it's resilience you're worried about, they have managed once or twice to take all of the data centers down in one go, but they're getting better at not doing that. So that was fun when that happened. Anyway, okay, so I'm going to move on to security and compliance next. I've kept this fairly short, but if you have any questions, either ask me at the panel or afterwards. It's a bit of a hobby horse of mine. So the first question, we don't get it as much anymore. People used to say we can't put our data in the cloud. About 2 or 3 years ago, that really flipped and people realized they should put their data in the cloud. But we still get the question sometimes. And the truth is, the answer is almost always yes, you can put your data in the cloud. I have yet to come across a scenario where you weren't allowed to, genuinely. Once you really look at the detail. I mean, customer contracts aside, but from a regulation legal point of view, the only one I've seen is with things like the NHS. They have some ambiguous wording in their guidance around if you move it outside of the UK, you should take extra care kind of thing. So you can put stuff in UK data centers if you need to. With Azure, I don't know the other ones, but with Azure, the UK data centers are about 25% more expensive than Amsterdam and Dublin. So, is it worth it for you? The other thing, but the main thing to really remember is that what these regulations are all about, whatever it is about control. It's about being able to monitor things, having auditing in place. So given that the rules are, look, you need to make sure that you can show us that nobody has seen your data, right? That's really what they're used to saying, those kind of things. There's no way on-prem you're going to have as good monitoring and auditing as you have in the cloud. There's just no way you're going to do that. There's no way you're going to have the same security stance. Each of the cloud vendors, they employ literally thousands of security people whose only job is to look after security on the cloud, okay? You're not going to match that. I guess not many people use backup tapes anymore, but if you do use backup tapes, have you got an access log for the cupboard? Because you should, right? If I can go into the cupboard and take a tape out, then I have your data, blah, blah, blah. In the cloud, you do have that access log. You can see who did that. Regulations, so I want to be PCI, FSA, ISO, you name it kind of thing. The cloud providers, by and large, have pretty much every certification you could possibly imagine. Of course, that doesn't make you certified, but it does make it a lot easier to become certified on the cloud. And again, I have yet to see one that can't be done up there. So usually, when people push back on it, it's more I don't understand this, so I'm going to pretend that you're not allowed, so I don't have to show my ignorance. That's usually that, or I don't want to learn something new, so go away. When you start pushing, it's usually always all right. And if not, reach out to the cloud vendor and they will help you. So, 2 more slides on security, I think. So the first one is just, because this is where confusion comes in. You might think I stick my stuff in the cloud and everything is well and I don't have to do anything more. That's not true. But you also get a lot more than you might realize. So the kind of things, firstly, you get these security procedures that are just next level. I went to see one of the data centers. I don't think they allow it anymore, but they're literally weighing people going in and out to make sure that, every single camera is doubled up. There's two, and you take a server out of a rack, there's cameras inside the rack looking at you taking the server out. It's that kind of security processes. The people who would be able to know what was on a given hard drive in the data center is not allowed within 200 miles of the data center. It's that kind of level. Now, With firewalls and denial of service protection, that is usually quite muddy, depending on what cloud you're in and what services you choose. So sometimes you have firewalls baked in, sometimes you don't. Okay, and you do need to look into that quite carefully to understand when you need to do more and when you don't. Okay, it's not obvious, and the documentation is often fairly opaque. If you use PAS, there's no concept of patching anymore, because all that happens is your servers just get replaced with pre-patched server images. If you are on VMs, that's your job. If you're on Docker, then the top tip is to use something like Dependabot in your to monitor for your Docker image dependencies and tell you to upgrade them and then do a redeploy, that kind of stuff. But again, it's your responsibility again. You get things pre-hardened. Again, to a point, you find that the images are certainly pre-hardened, but they don't always lock things down 100% because it's just really inconvenient. So you might find sometimes that you deploy something and then you actually do have to go in and tighten a few things up. So again, it's worth just looking into that, and don't assume it's all good, because it isn't always. You tend to get encryption everywhere. One of the reasons you do that by default everywhere is when the different cloud providers realized that the NSA and GCHQ had found out they could hack into their data centers and get unencrypted internal communication. So they switched everything to be encrypted everywhere, even internally, after that. So we all benefit from that from a compliance point of view, because of those naughty people over in Cheltenham, is it? And you get all of the auditing, and you get very fine-grained privileges, and you can really narrow down exactly what people can and can't do. Okay, but what do you need to do? Because there's more you have to do. So firstly, if you have bad code, your system is going to get hacked. There's nothing the cloud can do to stop a hacker getting in if you have XSS vulnerabilities in your code. That's your problem. So don't go thinking that's going to be solved for you. You've got to fix that yourself. If you really need to use a WAF, you can. Just wrong answer, but you can. As I said, you might need to set up a firewall. It's not clear when you do and when you don't. There are a ton of security tools, really clever ones using, some of them use static rules, a lot of them use machine learning, where they are literally monitoring your software and detecting and figuring out what's the baseline. You know, I've got on all my databases, I'll get an email saying, hang on a minute, this user logged in and they don't normally log in. What's going on here? Is that really what's meant to happen? You get that kind of stuff but you got to switch it on, right? You have to turn it on. Some of it is free, some of it you have to pay for. So do go and look, and it is bewildering. You know, you go in Azure and they've got a dozen of them, and I'm sure the others are all the same. But if you don't switch them on, you're not going to help you. You should consider application level encryption. This is just standard stuff. Again, especially with the clouds, because they can integrate software and cloud provision, so it's become really, really easy to stick little bits of code in that transparently will encrypt certain bits of data in databases and in other storage systems up there, so only your application can read it. So even if you have a support person who is allowed access to the database, if they go and try and look at the credit card number column, it's encrypted. You can do that on-prem, but it's a lot of work. In the cloud, I have a video up on my website and shows you how to do it in about 20 minutes. You know, and that's some of the benefits you get, so there's really no excuse not to do it. Big cultural change is putting secrets and keywords or passwords, those kind of things. They shouldn't go in config files. They shouldn't even go in those nifty little configuration sections you get with your setups on the different cloud providers. They should go in these key vaults. They all have them, all the cloud providers. In fact, and that's a big culture change, because it's very, very hard, because it's less convenient. And you have to write a tiny bit of code. The code is a handful of lines, but getting your developers to take that change and do it, it's hard work, but you've got to push for it, okay? And do code reviews and all of that kind of stuff. So tell them, no, all of the secrets go over there in those keywords, those annoying ones, but they are super powerful. And if you ever get audited, really good things to have. Network isolation. So to make things easy, let's say on Azure I spin up, let's say a SQL database. And it's great because it says in there there's a firewall. And if I try and access it, I have to open up a port on the firewall or for my IP address, and it's brilliant. Except that anything on Azure can access it by default. So if I want to hack your database, I just spin up a VM in Azure, and then I can start prodding your database. That's really all it takes by default, and that's because it's convenient. So you need to think about setting up these virtual networks and do that network isolation to isolate your databases, your storage things, your backend microservice, all of those things from other tenants on the cloud. It's quite painful. It hurts my head whenever I try and do it, but you really got to just dig into it and do it. And then you've got to have your own security policies in your organization. Make sure you actually monitor things. Don't just give everybody owner access to your entire cloud tenant. Find out what they need, lock it down, and monitor the access. Look at the loaded files. And there's lots and lots of tools to automate that. Cool. Monitor, yeah, that's it. Good stuff. Okay. Oh, what's happening there? Let's try that again. Okay. Nope. Let's see. Oh, there we go. One thing I just want to say, and then I'll almost shut up, promise. This is a slide from, I do a presentation that's about an hour long about how to actually secure your web apps on Azure. And these are all the things you can do. But the thing I want to just stress to you guys is, traditionally, we have very much worried about stopping people getting in. So that means writing good code, putting firewalls in front, managing our secrets, network isolation. But what's much harder, or traditionally much harder to do, is this whole assume breach mindset. So I'm sure you all heard of that. So the idea that just assume they're already in, okay? How do you know what they're looking at, and how do you stop them getting further? That's quite hard to do, but with a lot of the tools in the cloud, that becomes a lot easier, because all of the green blobs on this diagram are basically all monitoring tools. And the idea is it's really easy to set up so that you can see when weird things happen and be told about it. And that really is the next level. It's no good just saying, oh yeah, my system is so secure, nobody can ever get in. If you have no way of knowing that somebody has breached your defenses, then you are not in a good position. You need to be able to tell. And that's where you really want to look. And I get quite excited when I go into that whole talk, because the tools are so awesomely clever. We even use it even just on the front end, silly things like being notified when the CPU starts spiking, because there might be somebody trying to probe you. Things like having an alert that says, oh, there's been a massive increase in 404s or 403s, because 404s usually means somebody's trying to probe you, right? If you get lots of them all of a 403s, somebody's trying to do privilege escalation attacks on you. And those things are really, really easy to do now. And then you just get an email pinging through saying, hang on a minute, this is a bit weird, what's going on? Then you go and look and you say, oh, hang on, somebody from Romania is trying to hack into our servers and cut them out, kind of thing. Very, very easy to do, but you got to do it. You got to switch it on, okay? Okay. Some more information. I can't read that. I'm Lytzen on Twitter. I've got most of what I write about Azure is up on neworbit.co.uk/Azure, and also on my website, lytzen.name. So if you want to see what I've been reading about or writing about, then it's all up there. Right, we've got a... There we go. That's the panel. So rather than taking questions now, if it's okay with everybody, assuming you have some, of course, is if we take the break and then get the panel up, and then, but before we do that, you want to say something else, I think. Is that right?
No, just so we'll have about 15 minutes break. So thanks so much, Frans, for that.
Thank you.